So up here on the board, I have drawn a circle, and I've drawn the radius of the circle out to this point. Let's call this point T. Let's call this circle R. All right, so we have circle RT, or R, and RT is a radius of circle R. And let's put one other point on this line here. So this is a line, like so. So it's got arrows. Let's just put this as point S over here. So a little bit of terminology for you and a couple of properties so that you can know how to work with these. This line ST, is a tangent line. Okay, so that's the first word I need you to know is tangent, or tangent line. And then point T is the point of tangency. So point of tangency would be another vocabulary that you need to know. So I'm going to refer to these quite often in the instruction in the next couple of days. We'll be dealing with circles and tangents to circles, points of tangency, things like this happening. So when I'm using these words, and these are new words to you guys, you need to know what these words mean and what they look like. So when I say tangent, we're looking at a line that touches the circle in exactly one point. Okay? And we're going to only deal with tangents on circles in this class, but in general, mathematically, anytime you have any kind of curve, you have a line that touches that curve in exactly one point, that's called a tangent line to that curve. The point where the tangent and the curve meet is called the point of tangency. And in circles in particular, the tangent line is going to be perpendicular to the radius of the circle at the point of tangency. So I know if I have a tangent and I have a circle, the radius and the tangent should be at right angles to one another. So this should be a right angle, this should be a right angle. And it kind of goes both ways. If I have right angles, then I have a tangent. If I have a tangent, then I have right angles. So our properties go both ways there. So quite often the test to see whether something is tangent to a circle or not comes down to the angle measures. If we see right angles, we know it's tangent. If we don't see right angles, we know it's not tangent. So when we look at example 1, we have this picture drawn. They're asking if KJ is tangent to circle P at point J. They've given us some numbers here to represent the lengths of the sides of this triangle. I know that if KJ is tangent to circle P at J, if this is the point of tangency, it kind of looks tangent, right? We just look at it, it looks like it kind of touches the circle just to J, but maybe it does, maybe it doesn't, I don't know. But I know if it is tangent that this must be a right angle. Okay, if it is a right angle, then it's tangent. If it's not, then it's not. We can't go based on looks. Okay, when they give us numerical values, we have to use those values to establish properties. So I'm looking here at a triangle PKJ. I'm questioning whether angle J is a right angle. I'm going to put a question mark next to my right angle symbol because I don't know if it's a right angle yet. If that happens to be a right angle, what theorem needs to hold true in this picture? The Pythagorean theorem. Particularly KJ and PJ would be the legs and KP would be the hypotenuse. And you can see the outside piece here is 4, the inside piece is 6. The entire length of KP is 10. So if I just apply the Pythagorean theorem here and see if 6 squared plus 9 squared equals 10 squared, if it does, then it's a right angle. If it doesn't, then it's not. So if we just test that out, let's see that 6 squared plus 9 squared maybe equals 10 squared. 6 squared, of course, is 36. 9 squared is 81. 10 squared is 100. 36 and 81 make 117. 117 does not equal 100, which means that angle J is not a right angle. Angle J is not 90 degrees. And if J is not 90 degrees, then KJ is not tangent to circle P. KJ is not tangent. Now, when you get a question like this in your homework, that's kind of what I want to see on your paper. I want to see where you, don't just give me the answer, but give me some reasons why you know the answer is what it is. If this happened to come out true, 100 equals 100, then we would know J is a right angle, therefore it would be tangent. So again, just it really lends itself to understanding the properties and getting all this new knowledge really planted deeply inside your brain. So that's some of your homework will be involving whether or not things are tangent. Again, usually the Pythagorean theorem is going to be your go-to method for that.